13. It says draw the nuclear or isotopic symbol for carbon 13. So what information do we need to know in order to write a chemicals or the nuclear notation? You need the atomic number. You also need to know what the symbol is, right? So carbon is what symbol? A C. So I'm gonna write it up here. That way I have room for the rest of these. So C, and then we put the atomic number on top or bottom? Bottom. So we're gonna put a 6 down here. We're just grabbing this from the periodic table. Okay. So from the periodic table, your atomic number is always the number that's listed at the top. Okay. And then we are going to put 13 above it. Aww. My bracelet. Okay, that's okay. All right. So there's our nuclear symbol. Looking at this, how many neutrons are there? Nope. 7. Good. Just put that there. Keep practicing that in your brains, okay? All right. Calculate the number of neutrons in copper 66. So let's go ahead and write our isotope notation again, just to kind of help us out. So copper is Cu. Our atomic number is the number 29. Our mass number is given to us in our your isotope name, which is what? 66. So neutrons are going to come from 66 minus 29, and that number is going to be a number. What is it? Thank you so much. 37. Yes, that sounds right. All right. Okay, number 16. Calculate the number of protons, electrons, and mass number for oxygen 18. So oxygen 18. So once again, I'm going to write my little nuclear notation. So I know oxygen, looking at my periodic table, has an atomic number of 8. Right? So once again, we're just looking at periodic table. Sorry, I don't mean to cover the whole thing. Oxygen has an atomic number of 8. We're not going to grab our atomic mass because we know where that came from. Okay, so 8. We're going to put on the bottom. And we're going to put the number 18 on top. So, protons. How many protons does that one have? 8. How many electrons? 8. If this was a -2 charge, okay, so if it was a 18, 8, and then we had a -2 right here, what would the electrons now be? 10. We need 2 more negativity. Does that make sense? So it would be 10. Okay? So just remember, that's your little ion thing. All right. So for the neutral one, though, let's finish that one out. Neutrons, we're going to get it by subtracting 18 minus 8, and we get the number 10. Okay? This one, same thing with the neutrons. This is an isotope. So you can have an isotope that is an ion, just so you know. Okay? I know we've kind of kept them split, but you really can have both. All right. Okay, next one. No. So determine the number of protons in silicon 30. How many protons does that have? We're not even going to write the nuclear notation. Where are you going to look? Your periodic table. Just so you know, that's the main one. That's actually your example. How many protons does he have? 14. 14. We got that from the atomic number. All right, number 18. If phosphorus 33 contains 15 electrons, determine the number of protons it has. It is 15 because we're not talking about an ion. There is a phosphorus ion. It has a -3 charge, but we're not talking about that. So since it's neutral, we can go ahead and say A equals P equals E. So therefore, 15, oops, I was going to write out the word, 15 electrons. Okay? I'm so sorry. If you guys want to tilt your desks, I'm supposed to have you guys in rows. I feel bad that you're like looking over your shoulder. You're okay, okay. If anybody needs to move their desk, you can. For that one, determine the number of protons. Oh, sorry. Yes, you're right. Thank you. They gave us electrons. My bad. All right, so 15 protons. Awesome. We could have also just looked up phosphorus, right? And it has the atomic number of 15. All right, number 19. An isotope of indium has 49 protons and 70 neutrons. What is the mass number? So we're going to write its isotope name. So we're going to say indium. We're going to put a little dash, and we're going to put our mass number after. So what is the mass number, given that information? So we're going to have a 9 for sure. 119? Should be indium 119.
Is that with the AMU or just grams?
So when we're writing the name, you don't include that. And technically with mass numbers, we're not going to include it because those came from counting, right? When we're measuring, when you have the decimals, then we usually use AMUs. Okay, so all of the ones on the periodic table technically end in AMU. Okay. All right, number 20. Here we go. This is more like what you're going to see tomorrow. Just hint, hint. You might put a little star here. All right, name the particle described in the diagram and give its charge. So if this is the particle and it's going that way, it's a negative charge. Negative charge. So negative. So which one is negative? Proton or electron? Electron. Okay, do you guys need help with that one? Because I heard a lot of different answers on that question. Does anybody need help with that one?
Yes, I'm confused.
Okay, so name the particle described in this diagram. So this is your particle source, meaning this is kind of like a thing shooting out a laser beam, right? So we want to know in that laser beam, if those particles head this direction, and you know that this is a positive thing, this is a negative thing, I'm asking you what type of particle was that? If it's attracted to the positive and repelling the negative. So since it's repelling the negative, that's a negative thing coming out of this particle source.
Okay, so I think where the confusion was coming from here is that we thought that because that's a particle source positive, we thought that it was saying that its charge was positive. The picture is not very.
Okay, so this is just our little easy way of making this picture, just so you know. Okay, so but yes, thank you for clarifying that for everyone. That's good. Does that make sense now? Particle source just means this little part. This is where the laser beam comes out. And we're looking at, is it bending away from the negative or going towards the negative? If it bends away from it, that means it's a negative thing coming out of the particle source. And if it goes towards the negative, then that means it's a positive. But I will just tell you, with that experiment, it was negative, right? So we're probably not going to give you a positive thing coming out, if that helps. The answer is negative. Always negative, and it goes towards the positive thing because it's attracted, like magnets. Remember, this is the magnet thing that we had talked about. Okay, all right, do your best on it. If we gotta relearn it again on Tuesday when I'm back, we will do that, and we will take a short little redemption quiz, and we'll just kind of get that question back. Okay, all right.